Now we're going to take a look at a conceptual data model and 4 possible physical implementations. The conceptual model we're showing in this course is for an order processing application, a very simple one, where a customer can create an order. The order has items which have a quantity and maybe a discount, and each item has a related product. But the customer also has addresses, has contacts, and has pay types. But notice the order. The order also will have one or potentially more addresses, shipping, billing, etc., and will also have a pay type available to that customer, which is being used for this particular order. We've implemented 4 physical models. We're going to briefly survey them and then set you loose to dig into the JSON files in detail. First, let's start with an anti-pattern. In Couch Gadget 1, you'll notice a few things wrong here. First, notice that the entire document has a single attribute as its root, and that attribute is being used to identify the document type as an order. Although this approach does make for easy identification of the document when you look at it visually, it creates unnecessary nesting when you go to programmatically query the data. Also, the entire conceptual model here is being expressed in a single document. While very small applications might need only a single document, in an application of any real size, trying to put all the data in one document will result in unnecessary and unhelpful data duplication. So the entire document expresses a single order, which in itself is not bad, but we see here that the items are an array of fully duplicated product objects. Each product has an order-specific quantity, but it's all munged together with other product data which potentially would be used in many different orders, in every order: the name, description, warranty, and price. Similarly, you see the customer object is a single object that's munging together customer and contact data, customer name and ID, along with contact information like email and Twitter. The address values are munged into the customer object without distinguishing whether it's billing data, shipping data, etc. Last, we see pay type information, some credential for PayPal. Obviously, it's simulated here. Is this the only order this customer will ever make? We certainly hope not. All in all, don't do this. Now in Couch Gadget 2, in our second implementation, there's really only one change. It's still the entire model in one document. You shouldn't do that. But we've made a fundamental change. Instead of nesting the entire document in a single root attribute to indicate the type, the document has all of its attributes at the top level, barring further nesting, such as in the items array, and we've added an attribute of type to indicate the general type of this particular document. This is a recommended practice because it enables easy indexing. Now, nickel is outside the scope of this course, but I want to make a point of just how easy it is to index and query with nickel. Here, an index is being created for all documents in the Couch Gadget 2 bucket for all of their type attributes, and then we can execute select items from this bucket where type is order, and we would get back all of our orders. If we enhance that index to include both type and ID, then we can do millisecond or faster lookups directly from cache memory of every order by its ID. Nickel is powerful. Check out our online CB110 course to get a jump start on learning how SQL for JSON can be put to work for you. But let's keep moving here. In Couch Gadget 3, we've gone for complete normalization because there's nothing to prevent you from doing that in Couchbase. All of our entities are in distinct documents, and all cross-document data access would then be performed through nickel joins or SDK get operations. So here in the order, which is what we're looking at, all the reusable data like customer information, address information, product information, pay type information are all accessed by document IDs. The document ID is here so that you can grab that information, join it, or do a subsequent get, but only if you actually need it. The items is an array of objects referencing product ID values. It includes an order-specific quantity and possibly a discount if it's relevant, otherwise it's missing, We've already seen how that's no issue for nickel. Now the product information you'll see is in a remote document as is simulated here. One difference though, notice that the product ID is just a number. The prefix for product though is part of the document ID. In the CB110 course, we'll show you how you can modify values like this directly as part of a query, and of course you could modify the document name that you get directly in an SDK. The customer document is accessible via customer ID. For address, we see a document ID for a shipping address. Now in this case, notice that the type of address is encoded as part of the attribute name. We'll see an alternative to that ahead. Also notice that the address type, meaning shipping address, is both in the document ID, address shipping BIPCO 2345, as well as in the attribute name. Is that a good idea? Is it not a good idea? Well, this is where art comes into play in how you will end up choosing to design your documents. The pay type, here we see we have a document ID, pay type PayPal, with both customer and payment type identified in the key. Now we'll move on to Couch Gadget 4, because what if you need to relax things a bit? So here our entities are partially denormalized, or to put that in simpler terms, there's some duplicate data, because sometimes that speeds things up and provides other benefits. So again, remote data access would come via SQL join operations or SDK gets. But here, our order mostly references reusable data, but there is some duplicated. Why? Because local data requires no additional join or get. That may be important if, for example, you're loading documents into mobile devices. But where you have duplicate data, you need to think about long-term data integrity, and so the common practice and pattern is to add timestamp in some appropriate manner so where you have duplicate data, you know which is more current and can update as appropriate. Here, our items and products are again an array of reference objects with only a partial document ID, no type prefix as we saw in the last example. Here we have an order-specific quantity for each item, but notice that the name and the warranty are duplicated locally in the order from the remote product document. That would allow that data to be used immediately along with this order document without having to make a subsequent request. But the remote document is timestamped so that you could periodically coordinate and update these documents as appropriate. Or, in the alternative, perhaps simply copying data from the remote document, the product, into the items here, means that the local data is the state of the product warranty and price at the time it was copied, in which case perhaps you would put a timestamp in the local document. So always consider, are you duplicating data or are you snapshotting the data? It's not the same thing. Third, we see customer is accessible via customer ID, but the name has been duplicated locally for fast access in this document without a subsequent get or join. And here we see a different approach to the addresses. The addresses in this case are an array of objects, and the type of address has been embedded as part of that object. Notably, it's embedded address : shipping in a manner that would be treatable as a prefix to the document name conventions that we've been using in these examples. But also see that here the shipping data is duplicated or snapshotted perhaps into the local document, while the billing address is a reference to a remote document. That might be appropriate for a given application. Your mileage may vary. And the pay type has the document and the payment types in the value as before. Now we have a lab in which you will download and take a look at all of these documents in detail. Examine them, see the choices that have been made in Couch Gadget 1, 2, 3, and 4. Sometimes the structure is different, even between orders within the same physical implementation, to show variety. So what have we learned here? First, implementing a complete conceptual model in a single document is generally speaking an anti-pattern. Embedding the document type as a top-level attribute rather than placing the entire document within a root attribute is a best practice. It supports easy global indexing with nickel. We also have seen that data can be fully normalized in JSON documents. There's nothing to prevent that. It's just that we give you the opportunity to relax. Selective denormalization is a real benefit to some access patterns. The remote data always remains accessible via nickel join operations or one or more SDK gets. Where appropriate, you would add timestamps to support data validation and updating where it's appropriate for your use cases. Last, we've seen how significant information, such as shipping versus billing address, can be embedded in document IDs, or you may choose to embed just some ID value and leave other prefixing to the get operations or nickel queries. You can always assemble the full document ID later in your code. Nickel makes it easy. In our next lesson, we'll come back to these documents again, but look at them in terms of relationships and cardinality.